Another learning day, everyone. This is Teacher Marlene, and now I am going to discuss another type of variation, which is the combined variation. I hope you learned from my previous video lessons on direct square, and inverse variation, because those are prerequisites of today's lesson. Are you ready? Let us start. Combined variation occurs when direct square, and inverse variation are involved in a problem. Let us start with the translation. So how will you translate the following phrases into symbols? Try this one. Z varies directly as X and inversely as Y. Are you ready to reveal the answer? The correct answer is Z is equal to KX over Y. Let us have more practice. How will you translate this? M varies directly as R and inversely as the square of Q. Check your answer if you have. M is equal to KR over Q squared. See to it that you are using capital letters as indicated in the given. How about this? The current varies directly as electromotive force and inversely as the resistance. Using I, E, and R as the variables, the variation symbol is I is equal to KE over R. Now, get ready to apply this in the problem. If Z varies directly as X and inversely as Y, and Z is equal to 9 when X is equal to 6, and Y is equal to 2. Find Z when X equals 8 and Y is equal to 12. So using the statement, Z varies directly as X and inversely as Y, we have to use this to find the variation symbol. So Z is equal to KX over Y. Then, using Z is equal to 9, when X is equal to 6 and Y is equal to 2, let us substitute this to find the constant of variation. So we will get 9 is equal to K times 6 over 2. Then, let us change 9 into fraction form and cross multiply. 1 times K times 6 is 6K. And 9 times 2 is 18. So, 6K is equal to 18. Dividing both sides by 6. So, the value of K is equal to 3. So, the equation is Z is equal to 3X over Y. Then, find Z when X is equal to 8 and Y is equal to 12. By substitution, Z is equal to 3 times 8 over 12. And 3 times 8 is 24. Divided by 12, so the value of Z is 2. Let's analyze problem number 2. If R varies directly as S and inversely as the square of U, and R is equal to 2 when S is equal to 8 and U is equal to 2. Find R when U equals 3 and S equals 27. Let us translate into symbol if r varies directly as s and inversely as the square of u. So we will get r is equal to ks over u squared. Then substitute r is equal to 2 when s is equal to 8 and u is equal to 2. So we have to use this to find the constant of variation. We will have 2 is equal to k times 8 over 2 squared. Change 2 into fraction form and multiply. We have 2 squared, that is now 4. So cross multiply, we will get 1 times k times 8 is 8k. And 2 times 4 is equal to 8. So 8k is equal to 8. Again, divide both sides by 8. So that the value of k is 1. So our equation, r is equal to s over u squared, since k is equal to 1. Now find r when u is equal to 3 and s equals 27. By substitution, r is equal to 27 over 3 squared. And the square of 3 is 9. Then 27 divided by 9 is 3. So r is equal to 3. Let us proceed to this problem. The maximum safe load of a rectangular beam varies jointly as the width and the square of depth and inversely as the length. A beam 2 decimeters wide, 2 decimeters deep, and 10 decimeters long has a maximum safe load of 1.6 kilograms. Find the maximum safe load for a beam of same material, which is 5 decimeters wide, 4 decimeters deep, and 16 decimeters long. Let us translate into symbol the statement, the maximum safe load of a rectangular beam varies jointly as the width and the square of depth and inversely as the length. We will use capital letter L for the safe load, W for the width, D for the depth, and L for the length. So we will get L is equal to KW D squared over L. Substitute 2 decimeters wide, 2 decimeters deep, and 10 decimeters long with a safe load of 1.6 kilograms to find the constant of variation. So 1.6 is equal to K times 2 squared all over 10. Let us change 1.6 to fraction. Then the square of 2 is 4 times 2 is 8. Then cross multiply 1 times k times 8, which is 8k. Then 10 times 1.6 is 16. So 8k is equal to 16. Divide both sides by 8 and we obtain k is equal to 2. So our equation, L is equal to 2W D squared over L. Then from the equation, substitute 5 decimeters for the width, 4 decimeters for the depth, and 16 decimeters for the length. So we will get L is equal to 2 times 5 times the square of 4 all over 16. 2 times 5 is 10 and the square of 4 is 16. So 10 times 16 is 160. Divided by 16, we will get L is equal to 10. Therefore, the maximum safe load is 10 kilograms. That's all for this topic. I hope you followed the process of solving variation problems. And before I leave, let me share this quotation. Your positive action, combined with your positive thinking, resulted to success. This is Famous by Shiv Kira. Thank you for watching and happy learning!